NASA was preparing to retire a spacecraft when an engineer proposed sending it to a comet. That sounds backward. Retirement is supposed to shrink a mission's future, not expand it. Yet Robert Farquhar, a flight dynamics specialist at NASA, was looking at a spacecraft called ISEE-3 and seeing something very different. While its original assignment was winding down, he was proposing one of the most unusual trajectory changes ever attempted. If he was right, a spacecraft built for studying the space environment around Earth could become something else entirely. If he was wrong, the mission would simply end. ISEE-3 had launched in the late 1970s to study the solar wind and the region where Earth's magnetic influence meets interplanetary space. It was never designed as a comet hunter. Its orbit, its purpose, even its identity belonged to a different mission. And that success created a problem. The spacecraft had largely accomplished what it had been sent to do. Mission success was becoming mission risk. Once a spacecraft finishes its primary job, the easiest future to imagine is no future at all. From a distance, the story appears finished. But Farquhar was asking a different question. Not what the spacecraft had done, what it could still become. At almost the same moment that ISEE-3 was approaching the end of its original usefulness, another opportunity appeared far beyond its intended destination. A comet called Giacobini-Zinner would pass through a geometry that made a close encounter possible. Possible did not mean easy. The comet was moving along its own path. The opportunity would not wait. The window existed for a limited time, and the spacecraft available to reach it had never been designed for that purpose. A route map of the comet's future position revealed the mismatch immediately. The destination was real. The spacecraft was real. The path connecting them was not. At least, not yet. The obvious solution would have been power. Build a dedicated spacecraft, launch something new, use large propulsion maneuvers to reshape the trajectory. But those were not the conditions of this story. ISEE-3 already existed. The comet window was approaching, and conventional navigation demanded resources that were difficult to justify for a spacecraft originally built for another mission. One by one, ordinary options weakened. The direct route looked cleaner on paper, but it depended on capabilities the spacecraft did not comfortably possess. The list of available futures began to shrink. And that is when the moon entered the story. Not as scenery, not as a destination, as a tool. Somewhere on a trajectory map, the lines started looking wrong. Instead of a clean outward path toward the comet, the route looped back toward the Earth-Moon system. It curved and folded. It seemed to waste distance. To anyone expecting a straightforward chase, it looked irrational. But Farquhar was tracking something more important than distance. He was tracking what options remained. The spacecraft could not rely on fuel to perform the entire job. So the route would have to borrow momentum elsewhere. Gravity would become the missing resource. The hand-drawn trajectory maps from the period are striking because they almost resemble mistakes. Loops curl around the moon. Paths bend where intuition expects them to continue outward. The spacecraft appears to wander. Yet each loop serves a purpose. Every lunar encounter changes the spacecraft energy. Every flyby nudges the trajectory. Every pass uses celestial mechanics as a substitute for propulsion. The moon was no longer background scenery. It had become part of the engine. That realization changes the meaning of the map. The loops stop looking inefficient. They become the mission. Still, understanding the plan was not the same thing as executing it. A trajectory drawn on paper is forgiving. Space is not. Each lunar flyby had to occur at the correct place and time. Every encounter influenced the next one. The route depended on geometry, and geometry does not negotiate. A small error early in the sequence could reshape what happened later. The pressure inside the story changed. The question was no longer whether a solution existed. The solution existed. The question was whether reality would follow the map. As the spacecraft moved through the flyby sequence, the old mission began to fall away behind it. The orbit associated with its original purpose was no longer its future. Each pass around the moon committed it more deeply to a different identity. The route was becoming irreversible. One successful flyby preserved the next opportunity. Then another. And another. The spacecraft was gradually escaping the future everyone had expected for it. By this point, something else changed as well. Its name, ISEE-3, became the International Cometary Explorer. ICE. The renaming mattered because it transformed the mission from an extension into a commitment. A spacecraft originally built to study Earth's space environment was now officially dedicated to comet exploration. But names are easy. Trajectories are hard. The new identity still depended on a destination that had not yet been reached. The wager was now public. Everything rested on whether the route would actually deliver the spacecraft to the comet. Years earlier, the strange loops on the trajectory map had looked like a detour. Now they stretched behind the spacecraft like a chain of decisions that could no longer be undone. Ahead waited Giacobini Zinner. The final test was simple. Either the route worked, or it didn't. In September of 1985, ice reached the comet. The encounter transformed the entire sequence of lunar flybys from theory into evidence. The trajectory was no longer an elegant idea. It was a completed path. The spacecraft gathered data during humanity's first close fly-through of a comet. The opportunity that once seemed mismatched to the machine had become a historical event. And in that moment, the achievement was not merely the comet encounter itself. The achievement was the route. The spacecraft had not been rescued by a larger fuel supply. It had not been replaced by a newer vehicle. It had not been given a second life through brute force. Instead, a shrinking set of options had forced a different kind of solution. Gravity replaced fuel. Timing replaced power. A trajectory replaced capability. The opening image of this story is a spacecraft nearing retirement. The closing image is a trajectory map filled with loops around the moon. At first glance, that map appears to lead nowhere. By the end, it leads to a comet. And that is what changed. The spacecraft did not reach Giacobini Zinner despite its limitations. It reached the comet because those limitations forced someone to search for the one remaining path that still existed. The strange route that looked wrong in the beginning became proof that the mission was never really saved by the spacecraft. It was saved by the trajectory.